Welcome you all for today's discussion of from the subject of design and analysis of algorithm. Today we are going to discuss a topic on binary search. So I'm Sherine Glory, Assistant Professor from Department of Computer Science and Engineering from RMD Engineering College. So we are moving on to the topic. So what is introduction given? So what is binary search? So binary search is an algorithm that finds the position of the target value within the sorted array. So we all know what is binary search. Binary search is also known as in half interval search or logarithmic search. So this binary search is going to work on the methodology called divide and conquer algorithm. So this can be implemented only on the sorted list of elements. So it cannot be implemented on unsorted list of elements. So what is divide and conquer? We have seen that it is going to work on divide and conquer algorithm. So divide and conquer algorithm is the most well-known algorithm strategy. So the algorithm works by recursively breaking down the entire solution, entire problem into small sub-problems and solving more than one sub-problems, and then finally we will be conquering it. The solutions of the sub-problem are combined and to give us solution to the original problem. So we have taken an example of binary search. So we have an array that has been given. So first we have to check whether we can apply this binary search or not. So as the characteristics of binary search says, it can be applied only to the sorted arrays. So if you see this array, it is an sorted array. Okay. So I have to find out an element called 37. Okay, so that is what I am going to find. So according to my binary search algorithm, so see here they have specified if 37 is equal to A of mid. So what is the size of this array? This is of size 9. Okay, so 0 to 9. So this is my entire size of my array. So 0 to 8 they have specified. Size of my array is 9. So I have to find out the mid value. Okay, so from the array, this is my minimum value and this is my maximum value. What is my min value? It is 0 and maximum value it is 8. Okay, so now I have to check, and what is my mid position value? Mid position value is calculated with the formula called min plus maximum by 2. So what is my min? 0. 0 plus maximum 8 by 2, it is 4. So this is my mid value. So I have three values. One is min, max and mid. So what is this element I am going to search? 37. I am going to check whether it is in the middle or not, first thing. Okay, so based on that only I am going to take a decision whether I have to move towards left from the mid or right from the mid. So I am checking whether 37 is equal to A of mid or not. If it is equal to A of mid, so A of 4 is 37, means I have to return, I have found out an element, this is the position. So mid value I will be returning. If not, I will check whether this 37, okay, is less than A of mid. So this is not true. So here it is 45, right? So I am checking whether it is less than A of mid. What is A of mid? It is 45. So 37 is less than 45. Yes. Okay. So if it is true, I will move on the search to the left side. That's what they have said. It is half interval search. From the very first step itself, I will find out. I am not going to, like a sequential search, I am not going to check each and every positions. Here I am only going towards only the left. I am going to neglect the right. So okay, so if it is true, I am going to assign the maximum value as mid minus 1, because mid has been already checked, so it is going to be reassigned as mid minus 1. If it is not true, say for example it is 55, so 55 is greater than 45, so then I have to move on to the right. So if it is not true, I have to move on to the right. Since mid has been already searched, already checked, I have to reassign my minimum value as mid plus 1. Okay, this is the basic operations in my binary search. So if I am repeating this procedure, I will be able to find out the element. Okay, so this is an input. A is an sorted array, n is the size of the array, key is the value to be searched. So I am setting my minimum value as 0 and maximum value as n minus 1. So what is my n? It is size of my array. So in array we used to have maximum size as n minus 1. So I am having a conditions while min is less than max. Yes, min is less than max. I am going to set my mid value as min plus max divided by 2. So After finding the mid value, if t is equal to a mid, I am going to return mid. Else if I am going to going to check whether it is less than mid, I am going to reset my maximum value. If it is greater than mid, else I am going to reset my minimum value, and this procedure will be repeated until I find the element that has to be searched. So what is the time complexity of this binary search algorithm is, the worst case time complexity is big O of log n, and average cases big O again of log n, and the best cases, say for example I have found out the element is found in very first stage, that is A is the searching element is equal to A of mid. So 45, say for example I am searching an element 45, so it is present in the mid element, right, mid position itself. So the very first search I am going to achieve finding the solution, so then it is given as O of 1. So that is what the time complexity has been calculated. Hope you find it useful and able to follow this particular binary search algorithm. Thank you.